Hey everyone, welcome to Module 1 of our Veterinary Epidemiology mini-talk series. Today we're tackling risk ratios, also called relative risk, and by the end of this talk, you'll be able to calculate one, interpret it, and explain why it matters in a clinical or research setting. Let's jump right in. So what exactly is a risk ratio? At its core, it's a comparison. We're asking if an animal is exposed to something, a pathogen, a drug, a risk factor, how does their probability of getting sick compare to an animal that wasn't exposed? It's one of the most intuitive measures in epidemiology, and it shows up constantly in cohort studies and clinical trials. Before we get to the formula, let's talk about the 2x2 table. This is your best friend in epidemiology. Every measure we cover in this series lives inside this table. The rows represent exposure status, the columns represent disease status, and the cells A, B, C, and D hold the counts. Get comfortable with this layout because we'll use it in every single module. Formula. We divide the risk in the exposed group by the risk in the unexposed group. The result, the risk ratio, tells us the magnitude of association. An RR of 1 means no difference. An RR of 3 means exposed animals are 3 times as likely to develop disease. An RR of 0.4 means the exposure is actually protective. Maybe it's a vaccine or a preventative treatment. Why does this matter to you as a veterinary professional? Because risk ratios show up everywhere in herd health decisions, in outbreak investigations, in the journal articles you read, and critically, they give you a number you can actually communicate to a client or a producer, saying unvaccinated animals are 4 times more likely to get sick is powerful, actionable information. All right, here's your practice problem. Take a moment to pause the video or work through this before moving to the next slide. We've got 200 cattle exposed to contaminated water, 200 cattle with clean water, 40 infections in the exposed group, and 10 in the unexposed group. Build your 2x2 table and calculate the risk ratio. Go ahead. I'll walk through the solution on the next slide. Walk through it. We fill in the table. 40 infected in the exposed group, so 160 were disease-free. That gives us our 200 total. Same logic for the unexposed. 10 infected, 190 disease-free. Risk in the exposed group is 40 divided by 200, which is 0.2 or 20%. Risk in the unexposed group is 10 divided by 200, which is 0.05 or 5%. Divide those. 0.2 over 0.05 equals an RR of 4. Our interpretation, cattle drinking from the contaminated water source were 4 times as likely to develop cryptosporidiosis. That's a clinically meaningful and actionable finding. It tells you exactly where to intervene.